SmartSuite Automations now support branching. One automation can handle multiple execution scenarios based on provided conditions. Today I will show you 3 workflows, each adding a step in difficulty. First, a simple 2-branch split, the one you'd be using most often. Then, a branch nested inside another branch. And finally, a loop running inside the branch. In this demo, I'll be using an enterprise risk management solution from our GRC suite. In this solution, a company keeps a risk register, a list of things that could go wrong. Every risk gets analyzed, scored, and then decided whether to mitigate or fix it, or accept and live with it. Risk belongs to a certain domain: operational, cybersecurity, financial, and each risk domain has a set of its own attributes, which we will also be using in this showcase. Our first automation watches for changes in the risk response field, and as soon as it changes, it pulls the domain record that this risk belongs to. And now when we have the context from both tables, we'll create a branch. The conditional logic option sits under Advanced Logic section. As soon as you add it, you'll notice the change in the UI. The left side of the screen turns into a zoomable canvas, and the right side shrinks but remains resizable, so you can make it wider anytime. And now I will define conditions for the branches. And here goes the important part. When defining those conditions, I am free to mix and match values from various sources. And that's exactly what I need here. The first branch should execute when risk response from the trigger is accept and risk alignment from the linked domain is over its appetite. This attempt to accept the risk will result in escalation because domain is already overloaded. Inside that branch, we'll create a formal request in the risk acceptance table linked back to the risk. The second branch fires when the response is set to mitigate and domain's criticality is high. When it comes to execution, the automation evaluates conditions of each branch one by one. So depending on the conditions you've set, several branches can be executed. And finally, if needed, you can create a so-called final branch. It will trigger only if none of the other branches before it triggered. Let's go back to the escalation case. Assume the risk acceptance record we created requires a sign-off, but who signs depends on risk's tier. So inside that first branch, we'll add another fork. Tiers 1, 2, and 3 are the big ones. We'll create the same acceptance request, but with the required management review, and we'll put the risk itself into approval status. Tiers 4 and 5 are department-level stuff. The request will be filed, but will not require management review. Let's give it a test run. In order to reach that escalation branch, the risk should belong to the right tier, its domain must be over appetite, and risk response must be set to accept. Status has been changed to approval, and a new record in acceptance has been added and linked back to the risk. And of course, you can easily trace back the entire branching flow in the automation's run history. Here, every conditional block is represented as its own expandable node, making it very easy to understand why a particular record entered a certain branch. Now let's add a loop inside the risk mitigation branch. Every risk in this register can have linked key risk indicators, or KRIs. The moment someone commits to mitigate a risk, I want to increase the priority value of all related KRIs. Inside the mitigation branch, I first added the find record step. It collects every indicator linked to this risk. And then the looping action inside the same branch picks up that list of KRIs and updates their priority. It's time to see it in action. In order to activate that branch, I need to pick a risk that belongs to critical domain and set its response to mitigate. As you can see, its related KRIs now all have different priority values. So I'll let the automation run and check the risk record again. All KRIs have an updated priority value now, and the automation's run history confirms that the right branch was executed. It also shows separate nodes for every run inside the looping block.